Dependency injection. I've never been a fan of this naming because it sounds way fancier than it actually is. Dependency injection is just another name for providing services to your application. So for example, if you need to access the current session in your endpoints, instead of, hard coding everything and assuming you can get everything via the middleware, you need to inject the session. And this is important if you want to write unit tests, integration tests, or just want to mock things. So let me show you an example. We have the DebtsRepository, and this is going to be the data access layer for the database. So we have delete debt, we pass in the ID of the debt, we pass in the user ID of the current session, and we do the query here. So we do a delete from debts where ID is this one and owner ID is this one. And we just return the number of affected rows. So we can see two problems right away. First of all, the user ID from the session. The session is something that should be globally accessed by any endpoint. Why? Because the session is context for your backend application. And second of all, what about the database? We're importing database. In this case, we have the simple database driver that doesn't actually do anything, of course, that we're referencing directly within the repository. So there is no way for us to inject currently a database. As for the session ID for the user ID, yeah, we're injecting this. We're doing it via the arguments of the function. That means that in our service, we have another delete debt. Now the service is going to be the one that handles the business logic. Now, of course, if you see this code, they have the same names, the same arguments. Why don't you do this query directly in the service and get rid of the repository altogether? And the reason is because this application is too simple. But as your application grows in complexity, your services will be packed with business logic. So you need to separate the two. Maybe you need to call delete debt in multiple services. So that's why we have the two separated. Of course, for this contrived example, it doesn't make much sense, but this is merely an example to show you how to leverage dependency injection. Anyway, here we take in the user ID, so again, the session which should be accessible anywhere, and then we have deleted rows, so delete debt. We pass in the same arguments, and then we have the business logic. So if deleted rows is equal to 0, then we're going to throw an error saying, hey, that not found. Otherwise, we're going to return true. So now the consumer, the caller of this endpoint, can know what went wrong in the case that the debt doesn't exist, or they receive a true if it was successful. So now we can start drawing a mental graph. We know that the DebtsRepository requires the session. So that's one service that we need to inject basically. And then we have the service for the database. So we need to also provide or inject the database driver. And finally, the DebtsService needs to consume also the session to pass in the session. But in this case, we can get rid of this altogether because we know that this is now accessed via dependency injection. But we need to provide the service for the DebtsRepository because this should also be something that should be mocked. So even though the DebtsService only requires the DebtsRepository, behind the scenes, we need to provide the session to this DebtsRepository and the database driver whenever we use this DebtsService. But what about the controller? The controller needs the DebtsService as well. Now, this is fine. We can pass in this session. Of course, it would be nice to access it via context, but let's assume this is the highest level possible. So the controller is the one that is going to handle this session. So that's why we're passing this session over and we're drilling through passing this session to each call that needs it. But this can again be simplified with dependency injection. So in fact, instead of passing the session.userID to the DebtsService, to which the DebtsService will then pass over to the repository, we can just remove this and assume that here we have a controlled way to provide these layers, which are the services, so the session and the database driver, the DebtsRepository, whatever. But now, how can we achieve dependency injection in TypeScript? Well, TypeScript itself doesn't support dependency injection out of the box. You need to bring a third-party library for this, or devise your own, whichever you prefer. But this also depends on the framework you're using. If you're using something like Nest.js, I believe you have dependency injection out of the box. But if you're writing a Lambda function, an Azure function, or you're using a framework that doesn't have an intuitive way of achieving dependency injection, there's nothing else you can do other than bringing a library that does this for you. Now, what I'm going to show you requires some familiarity with the library. And for that, I just released a video titled Why I Stopped Using Async Await in TypeScript, an introduction to Effect. So if you haven't seen that video yet, or you're not familiarized with Effect itself, I highly recommend checking this video out. It is quite extensive, 32 minutes, but it is very informative. So make sure to check that out before continuing with this video. Anyway, Effect has a great solution for dependency injection. Now, again, if you're familiarized with Effect, you know that Effect looks like this. So we have effect.effect, we have the success channel, we have the error channel, and then we have the requirements channel. In the other video, I just touched upon the success and the error channels. I never talked about the requirements, or at least not in a practical way. Now, the requirements channel is a way for you to get dependency injection for free. So not only do you specify that your effects can succeed with S and the error could be a union of errors, you can also specify what context it requires or what services. So let's start with the utmost basic one, which is the authentication context. So again, we need to have a way to access the session in its entirety, not only the user ID, but the email, the ID of the session itself, whatever else you're going to have in that session. For that, you can just say export class AuthContext, and you just extend the context.tag and you pass in the same identifier. Now, this is convention. Some people like to prefix this with your organization namespace. Others like to name this the path of the file. So add source and then context management and then auth, whatever you want. In my case, I'll keep it simple, just AuthContext. And then you pass in a generic, you pass in the same class, and then we pass in the session. So this itself, the second parameter, will be the context, or what should be implemented for the service. So we have the auth service, which is just the session. So it is an object that contains a user ID and email, nothing more. Now, what about the database context? Well, if I come here, it is a little bit different because this time, as opposed to the auth context, which depends per request, so this would be injected by the middleware, the database context can exist right away. It doesn't depend on anything other than, well, creating your database client, whether that's with Kisely or Next or Prisma, whichever database driver you're using. In that case, our database driver is quite basic, just a function that takes in SQL and returns anything. Of course, this is just for demonstration purposes. So we do the same. We create the context with the tagged class, which is via context.tag, and then we define the structure of the context. So this context will have a database that is going to be type of DB. In this case, you'd have Kisely, Prisma, whatever. But now you need to create the live database context. So by convention, when you're creating the actual implementation that you're going to be using across your application, you name it exactly the same as the context, but postfix it with live, and live denoting that it is going to be used for your actual application, which makes sense if you think about it. And then we say layer.succeed. Now, the reason we say succeed is, well, just so we can get a layer back. So if I come here, as you can see, this is just going to return a layer. which is needed for effect. And then we pass in the class. So the class is actually the tag. So effect can map it over internally because it is going to have pretty much a map structure that is going to have the keys as the tags. So that's why this must be unique. And then it is going to have the resource in this case. So the actual implementation of the tag. So we're passing over the tag, which is this context.tag, and then we need to pass in the implementation. So in this case, we can say DatabaseContext.auth, or you can just say DB and you pass in the database, whichever you prefer. Now, if you come here at the type definition of auth, as you can see, takes in self, which is of type value, and it is just going to output the value itself. So it is just a generic identity function. Now I'm not sure in which cases this is better than simply not using auth at all. I'm not sure if it's because of performance reasons with TypeScript. I have no idea, but you can use whichever you want. So as you can see, this is the tag. It is going to add a private read-only tag, which is the discriminator. So this is what will be used internally to map everything. And it is going to add more information, but that's for internal work. And that's it. Now you have your live implementation of this context. Quite basic. Now if I come here to the DebtsRepository, now this is where things start getting complex, but not really. In this case, we declare the DebtsRepository, which is going to be a tagged context. And then we have the type. So the DebtsRepository is going to be an object which contains a method, which is delete debt, takes in that ID, and it is going to return an effect where it is going to succeed with number. So the amount of affected rows. It is not going to fail whatsoever. In reality, this could fail because the database driver is not successfully connected. It didn't establish a connection with the database, or who knows, whatever other reason. This depends on your client. In my case, my perfect client can never fail. So that's why I set it to never. However, it is going to require two services. It is going to require the database context and the AuthContext. So we do the same, layer.succeed, we pass in the DebtsRepository, which is the tag, which again is going to be mapped internally, and then we say DebtsRepository.auth, and we pass in the implementation. In this case, we say delete debt, takes in the number, and as you can see, we now have the actual logic because this is the live implementation. So we yield, we say effect.gen, which is going to be an iterator function. So again, if you're not sure about anything of this, go check out my other video. And we say const session is equal to yield AuthContext. And now we get access to session. How cool is that? And now we can do the same with database. So db is equal to yield database context. And then we can say const result is equal to, we do the query, we pass in the data. And as you can see, we're not passing the session because this assumes that the caller will provide this layer, this context. And then we return the result.affected rows, which is a number. So pretty rudimentary. Now, if I move over to the DebtsService, this one requires even more services. So again, we extend the tag, we create a context tagged class, and we have the delete debt. So we take in the debt ID, and then this is going to return an effect. And this effect is going to return true in the case that it is successful. It is going to result in debt not found if the debt doesn't exist, obviously, and then the requirements. So we need the DebtsRepository, but the DebtsRepository requires the AuthContext and the database context. So we define the three here. And then we can say DebtsService.auth, and we pass in the actual logic. So we yield the DebtsRepository, and then we can say DebtsRepository.delete debt. And this again is going to be the effect. So we get back the number of deleted rows, and then if it's 0, we just fail with that not found error, which is a tagged error. Otherwise, we return true as constant. And that's it. Now, how can we use all of these contexts together? How can we actually provide the implementations? So we have the live layers, but for our unit tests, we need to provide the services. So for that, if I come here to the main file, we create the controller. So we yield the DebtsService. So if I come here, this is going to require the database context, the AuthContext, the DebtsRepository, and the DebtsService. So we can see how nice this can be composed. Everything is neatly separated. And then we just say yield DebtsService.delete that. Now, how can we run this? Well, for that, we can create the all-encompassing layer, and this layer will contain all of the live services. In that case, for tests, well, you can create the app layer test is equal to layer.merge all, and you provide your test implementations. But in this case, we can say that service live, we provide the DebtsRepository live, we also provide the database context live, and finally, we can say layer.succeed right away, because remember, these one internally are using layer.succeed, which is going to return a layer. And then we pass in that this is going to be for AuthContext, so we pass in the tag, and then we provide the implementation. So we say AuthContext.auth, and we pass in the session. This can be provided by your middleware, depends on your application. And then to run this by providing the layers, you need to say effect.provide, and then you say to who you're going to provide. So you say delete that, you pass in the number, and then you pass in the app layer. And all you need to do is run promise. So this is going to return to you an effect that doesn't require anything because you have satisfied all requirements, but it can fail with that not found, and it returns true if everything went successfully. But this is very verbose, obviously. So for that, what you would do is create a managed runtime. So instead of before running promise, you need to provide everything, you can just create a runtime like run promise, like this one, that behind the scenes will provide all of the layers for your endpoint. So in this case, I called it endpoint runtime is equal to managed runtime.make, and we pass in the layers. And all you need to do is instead of effect.runPromise, you say endpoint runtime.runPromise. And again, this is going to provide everything. And then you can say, instead of result, you can say that's controller.delete that, and you pass in 1. And as you can see, everything works fine. If I say effect.runPromise and try to do the same, here, as you can see, we get a type error. Why? Because we need to provide all of these services. So that's why I would recommend creating a managed runtime for this. Now, let's say we have an Express server. So we have a middleware and we have a delete. How can we provide dynamically the context, at least for this session? We can keep the DebtsService live, DebtsRepository live, and DatabaseContext live within the app layer. But we shouldn't be providing the AuthContext here because we cannot dynamically set this context per each request. So for that, we can remove this. And by removing this, we now need to provide the AuthContext. So for that, I'm going to remove this line. I'm going to keep the endpoint runtime because this one is going to inject all of these services. But now, how can we, in the context of Express, do this? Well, for that, I created a type, request context, and we have the session, and the session is just a layer of AuthContext. Now this type, again, if I come here to this one, when we say layer.succeed, this will return a layer that is going to successfully return a DebtsService. It doesn't require anything, it won't fail with anything. So in that case, I just said that the type will be layer.layer and then AuthContext. And that's pretty much it. Now I declare global, so this way I can access the namespace of Express and modify the request to extend it. So we're extending the request interface and we're adding a request context. And by doing this, we now have our middleware. And in this middleware, you're going to validate the token. You're going to hit a database or a cache like Redis or your in-memory cache, whatever, and you're going to retrieve that session. In that case, all you need to do is say request._request context is equal to, and then you say session layer.succeed, you pass in the AuthContext, and then you say AuthContext.auth, and you pass in the session that you retrieved from the request. Obviously, I'm hard coding this, but you can imagine how this would look like with the actual logic. And then we call next. And then on our endpoints, to retrieve it, all we need to do is say request context, and we retrieve session. Now, of course, this shouldn't be optional. This should be required. And in that case, the middleware would throw an error if the user is not authenticated. Only if your whole backend requires a session, obviously. But Express isn't really a good solution nowadays, so I would recommend not using Express to begin with. Anyway, by doing this, how can we now run the controller? So we need to run the DebtsService.deleteThat because we need to provide the layers, so all of these layers, and also the session. Well, for that, that's pretty basic actually. We already have the endpoint runtime, which is going to provide all of the layers that we specified here. So all we need to do is say endpoint runtime dot run promise, and then what we need to say is delete that or that's repository or service. So that service dot, and right, it's the controller, not the service, and then delete that. We pass in the that ID and we get an error because we need to provide the session. So here all we need to do is say effect.provide, and then we pass in the effect and we pass in the session, which in itself is already a layer. And now we're good to go. The nice thing about this is everything is composable. So you can say effect.provide, you say to the that's controller, delete that, you pass in the that ID, you say I'll provide the session layer, and then you can compose this even further and you can say, for example, effect.catch tag, that not found error, you remap this into a new error, whatever, and then all you need to do is say endpoint runtime.runPromise. Now, the nice thing about this is everything is composable. Now, having a controller is redundant, so we can just say effect.gen, copy and paste this here, but you can come here and say effect.map, and then you get the result, and then you could, for example, return a 200 and the body result. So you can pipe this through, you can catch specific errors, you can handle them however you want. Anyway, this wraps up the video. If you want to see more content like this, make sure to like and subscribe. I'll see you in the next one. See ya.